Hello everyone, how are you? Welcome to our channel, Onlyphysics JEE Grad. Today we are going to discuss JEE Advanced PYQ, JEE Advanced PYQs for the topic from the chapter Electrostatics. Okay, it's a class 12th chapter, so we'll discussing this. Don't worry, I'm going to make a playlist for all these videos individually so that you can find it easily. So today's topic is, charges, conservation of charges, right? We have studied Coulomb's law, right? So these will be primary topics. Of course, in JEE Advance, the multiple topics will come in our chapter, in the questions. So we have to consider that too. So you will see there are questions from surface tension, SHM, etc., etc. So let's start. Okay, so another thing is today we are going to discuss 16 PYQs. Okay, let's start with our first question. So here it is. Perfect. So this is our first question. Let's start. We have keyword. There are two isolated metallic solid sphere of radius r and 2r. Perfect. Charge says that both these have same charge density sigma. The sphere are located far away from each other and connected by a thin conducting sphere. Thin conducting wire. Find the new charge density on the bigger sphere. Okay, so this question is like primary based on uh, potential difference, right? But there is a concept called conservation of charge, right? There is a concept called conservation of charge is used here. Okay, conservation of charge is also used here. So that is why this question we are discussing. Okay, let's start. So we have one sphere, we have another sphere. Perfect. Its radius is r, this radius is 2r. Let's suppose it has charge q2 and let's suppose it has charge q1. Initially it is given both of these have same charge density. So this is sigma, this is also sigma. Let's first find it. So sigma will be q1 upon 4 pi r square. Surface charge density is what? Charge upon area. And for this, it will also be equals to, yes, sigma will be q2 upon 4 pi 2r square, right? So it will be q2 upon 4 4 pi r square, right? We can write it like this, and both are equal, so we can write it q1 upon 4 pi r square will be equals to q2 upon 4 4 pi r square. Okay, 4 pi r square, 4 pi r square will get cancelled, so we will get a relation between capital Q1 and capital Q2 is 4 capital Q1 will be equals to Q2, right? Perfect. Now the second thing is given is the charges are located very far from each other. The spheres are located very far from each other. It doesn't matter, they are connected via conducting wire. So here, like, charges will start to flow such that potential at this point and potential at this point should be equal. Okay, let's say it will get a charge q1 and let's say it will get a charge q2. Perfect. Let's equate the potential of these. Okay, so Vp will be k q1 by r should be equals to k q2 by 2r. Okay, so this is a basic formula of potential at the surface of the conducting sphere, at the surface of any sphere. Okay, perfect. So k will get cancelled and r will get cancelled, so q1, okay, so 2 small q1 should be equals to q2, right? Now we can use another property which we call charge conservation. So what is that? Q1 plus Q2 should be equals to capital Q1 plus capital Q2, because charges should be conserved, right? Charges are exchanging from one sphere to another, right? But the sum of all the charges on both the sphere should be constant. Perfect. So Q1 as it is, For Q2 we can write 4Q1, and for Q1 we can write it as it is, and for Q2 we can write 2Q1, right? We'll get 5 capital Q1 should be equals to 3 small q1. Perfect. So Q1 we have to know. So Q1 will be 5Q capital Q1 divided by 3, right? Any issue here? No, right? Perfect. So the find the new charge density we have to find. So initially on the bigger sphere, okay? Be careful, on the bigger sphere it is written. So the charge density on the new charge density we can write it sigma dash. It will be Q2 divided by 4 pi R2 square, right? So the radius we know, we can directly just put it here. Okay, so let me swap the pen. It will be 2R square. So Q2 is what? 5 Q1 by 3 divided by 4 pi R square into 4, right? Right? So Q1, I can write it in terms of Q2, right? So Q1 is what? Q1 is what? Q1 is Q2 by 4. So I can just swap it. Sigma dash will be 5 Q2 divided by 4, right? And 3 was already there. And this will be 4 into 4 pi r square. Okay. So initially, what was the surface charge density? Q2 divided by 4 pi r square, right? So we can write Q2, this term, and these terms as a sigma, right? So we will get what? Okay, I'm doing correctly, right? So this is 5Q1 divided by 3, perfect. Okay, I have to put Q2 here, right? So Q2 is twice of Q1. Yes, this is a mistake. So Q2 is what? Twice of Q1, and I just written Q1. So I have to multiply it by 2. Okay, so it will become 10. Okay, that was the issue. Now this was sigma, so it will be 10 divided by 12 sigma. So what we'll get? Sigma dash will turns out to be 5 by 6, right? So 5 by 6 sigma will be our new charge density of sphere. Okay, so this question we can say it's an easy question, right? So it's an easy question, but it's a mistake prone question. Okay, so you can do mistake here, so be careful. Perfect. Let's move on to our second question. Okay, perfect. So it is something like satellite, right? Okay, we'll see. Perfect. Next question, we have two small balls, equal positive charge Q on each suspended by two insulating string of equal length L from the hook fixed data. Okay, so they are like this, and they have charge Q. Okay, perfect. The whole setup is taken in the satellite into space where there is no gravity. Okay, G is not there. The angle between the two string is okay. So it's an interesting question. Okay, let's suppose this angle is alpha and this angle is also alpha. Okay, so like the situation will be similar, right? So the both the angle will be same. Perfect. Okay, mg is not there. So let's suppose this is tension. I'm just taking generalized case. We'll get our answer. Don't worry. This is alpha. So the component here will be T cos alpha, and component here will be T sine alpha, and this will be electrostatic force between them. There is no mg. Okay, perfect. Now if I equate the force, so this situation is in equilibrium, right? In equilibrium we are talking about. So equilibrium we are talking about. It is not given here, of course. The equilibrium is not given, but the whole setup is taken as in the satellite. The angle between the strings is and the tension in the each string. So when they are asking this without mentioning equilibrium, we have to take equilibrium. Otherwise, okay, so why we do that? Suppose if we do not take, one person will say they are moving with the acceleration 2, another person will say they are moving with an acceleration 4. So what is the general consensus? This is not general consensus. Equilibrium will be the general consensus among everyone. Yes. So that is why we have to take it as equilibrium. Okay. Perfect. Now, so T sine alpha must be equal to FQ. And look, T cos alpha, there is no force to balance it. So T cos alpha must be 0. We know tension cannot be 0. If tension is 0, then FQ is 0 and FQ is not 0. So tension cannot be 0. That means cos alpha must be 0, which is alpha equal to 90 degree, right? So if it is 90, so what we'll get? We'll get T will be equals to FQ, right? We can put the values KQ square by R square. Okay, so look, what will be the R square? This I have to put. So alpha is 90. That means this whole situation should be like this, right? So R will be this, right? The length of the string is this, so R will be 12. So what will be the answer? K Q square divided by 2L square, which is 4L square. Okay. So angle between the two string is asking. It is not 90, it is 180 degrees. 180 degrees, and this is our force unit here. So again, it is an easy question, right? But you have to be careful. These are JEE advanced questions, right? So you need to be very careful. Next, let's move on to our third question. Perfect. So we have 5 point charges. Okay, each of value q coulomb are placed on 5 vertices of a regular hexagon of side L meters. Okay, the magnitude of force. What is the magnitude of force on minus q placed in center? Okay, remember, generally we can just write it directly like 0, but on the hexagon there are only 5 charges. So it's 1, 2, 3. I can place it anywhere, okay? I'm not placing it just here. So it's like this. So this is Q, 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 and Q. Okay, let me change the color so you understand that only these 5 places has a charge. Okay, the side of hexagon is A, right? And there is a charge placed in the middle, which is minus Q. So force we have to find. This is an extremely easy question, but you have to be careful. So these force will get cancelled out, right? These force will also get cancelled out. Okay, this force will not get cancelled. So what will it be? This distance we know. This is actually A, right? In a hexagon, this is angle 60 degree. This is also 60 degree, and this is also, so it's A, right? It's an equilateral triangle. Okay, so this is A. So force will be what? K simple Q square divided by A square. That's it, right? So it's a very easy question, of course. Next, move on to our fourth question. Okay. So what is saying, two identical metallic spheres of exactly equal mass are taken. Okay. One is given plus Q, another is given minus Q. Okay. The masses after charging are different. Definitely. Look, they were initially uncharged. So let's say identical sphere, they have equal mass. Now, one is given a positive charge. So how will give it positive? We have to take out electron. And we know mass of electron is 9.1 into 10 raised to power minus 31 kg, right? So it will have m minus del time. And if I have to give it a negative charge, I have to give electron to it. So it will have m plus del time, right? So both have different masses. So that's a true statement. It's an easy question, of course. Let's move on to our next question. Okay, perfect. So it is given. Okay, that's this question is actually hard. Okay, it's a pretty typical question. I can say it's hard. It's a typical question. It will consume your time. Okay, let's start. A rigid insulated wire frame is form angle at triangle ABC. Okay, set vertical plane. Two beads of equal mass M and N. These are our beads. Okay, these are our beads. Q1 and Q2 are connected by a length. The cords of length L will slide without friction, considering the case to be stationary. So equilibrium. Okay, everywhere there is equilibrium. Don't worry about that. Determine the angle alpha. Okay, we have to find this alpha. Okay, look, first of all, generally the questions are given like that, and you assume these and these two are parallel, so alpha is 30. No, right? Okay, let's make a diagram like this. Perfect. So this angle is 30 degrees, this is 60 degree. We have to make like this. Suppose this is here, this is here. Okay. And then we have to connect it with a wire. Okay. So this alpha is, we have to find. Perfect. Tension in the string normal. And if this rod is cut, this cord is cut, then the value of the charges for which beads continue to remain stationary. Okay. So let's start, shall we? Okay. So let's make the free body diagram for this. Okay. So force due electrostatic force will be here. Okay. If both are positive charged, right? Equal charge carrying Q1 and Q2. So both are equal. This is Q. This is also Q. So this is one. This is our second. Perfect. Okay. So FQ will be this. MG will be in the downward direction. Okay. Some other force. Yes. There will also be another force. This we call it as tension, right? This wire will be pulling it, right? Now, as the speed is connected to this wire or cord, whatever you call frame, this is frame. So there is a normal acting on the speed, and this normal will be definitely perpendicular to the surface. So this is our surface. So it will be either here, yeah. So it will be either here or it will be either here, right? There will these two direction is only possible. So you can take any direction. Okay, what can we take? So let's take the direction in, let's take this direction. Okay, normal, remember, normal is always perpendicular to the surface, right? Perfect. Now, how do we resolve these forces? Um, can we resolve these forces in this direction, right? Because I don't want components of normal. It will give me a headache, right? So I don't want it. So always, if there is an inclined plane, try to resolve in the inclined coordinate axis. Okay. So this will be our x, this will be our y. So perfect. Let's resolve it. Here we will get t cos alpha, and here we will get t sine alpha. Okay, if this is alpha, then this is also alpha. So we will get here f q cos alpha, and we will get here f q sine alpha. Okay, mg I have to resolve also. Perfect. Yes. So this is alpha. This is 90 minus alpha. But wait, this is 30 degree and this is 90 degree. So this must be 60, right? This must be 60. So here we will get mg cos 60, and here we will get mg sine 60, right? Be careful by resolving these. Perfect. Okay. Now let's resolve, as this is in equilibrium, these forces will be equal to this. So I can write it here as T cos alpha must be equals to F Q cos alpha plus mg cos 60, cos 60 will be 1 by 2, right? Okay, now this FQ sine alpha plus normal should be equals to T sine alpha. So let me write it in a opposite way. Okay, so it will be T sine alpha plus mg. Sine 60 will be root 3 by 2. I'm just directly putting those values here. Will be normal plus fq sine alpha, right? So I can see that this t cos alpha, fq cos alpha, and this is t sine alpha and fq sine alpha. Let's rearrange them. So it will be t minus fq cos alpha should be equals to mg by 2. Perfect. And from this we can write it as t minus fq sine alpha should be equals to normal, and we can take this here minus mg root 3 by 2. Perfect. So this is our first equation and this is our second. Perfect. Let's resolve this force on this charge also. Okay, so this F will be same, so I'm just writing it as a FQ. Okay, mg will be in the downward direction, right? So this will be our mg. Perfect. What other we have? Mm, other force. There will be tension also, right? Tension is like this, and there will be normal, of course, on the perpendicular to the surface. So this Q will experience. Where should I take? Okay, let's first resolve it. Then I can take normal, so that our calculation will be easy. Okay, you can take it anywhere, but let's first resolve it, right? So again, I'm going to resolve it in this frame. Okay, so it's like a frame of reference in the inclined plane. Okay, perfect. So this is alpha. Look, what will be this angle? This will be 90 degree. Why? 90, 30, 60. This is a triangle. So it will be 90 minus alpha, right? Okay, no issues. Uh, this angle will be 30 degrees, right? So mg's first component will be mg cos 30 here, and here will be plus mg sine 30. Okay. So it will be like that only. I will zoom in. Don't worry. I'll zoom in. Let me zoom in first. Let's zoom in this part. Okay. This side I can zoom in, right? Okay. No, I have to zoom in this whole part. Hmm, okay. I can directly zoom in like this. Yes, I can directly zoom in like this. So this to rub it, it will be what? Plus mg sine 30 degree, right? Perfect. This will be t. Okay, fq is here already. Mm, let's go with the normal here. Okay, shall we? There is no issue. Okay, perfect. So this axis will be like this. Okay, it's not necessarily perpendicular to this fq, right? So it's like this. You have to take the perpendicular axis, right? So I have to rub this part. This axis should not be there. Okay, perfect. Now this is 90 minus alpha, so this must be alpha. So if this is alpha, then this will be alpha, right? So now the component of fq will be what? So component of fq will be fq cos alpha here and here FQ sine alpha, right? So we have resolved mg, we have resolved tension, have we? No, we have not resolved tension, right? So this must be alpha. So tension one component here will be, so let me resolve it here. So it will be T sine alpha, right? So T sine alpha, and mg's sine component will be in this direction, right? So it will be in this direction. What will it be? Mg sine 30 degree, right? So we have these two forces and we have these two forces, right? So mg sine alpha will be here, mg sine 30 degree will be here, and t sine alpha will be here. Similarly, for fq sine alpha will be here, and mg cos 30 degree will be here. And for t, this is t, so here we will have t cos alpha, right? Any other force here? No. Okay, perfect. So let's resolve it here. We can write T cos alpha must be equal to this force, right? These two forces. So we can write it here. T cos alpha should be equals to, let's write it here. So T cos alpha should be equals to FQ sine alpha, right? FQ sine alpha, that is correct, right? So this is alpha, this is 90 minus alpha, so this must be alpha. This is alpha, this is alpha. Okay, perfect. It looks fine, I guess. Component of T will be T. Okay, so this is wrong. It won't be T cos alpha. Look, this is T, so T cos alpha will be here, and this will be T sine alpha, right? So it will be T sine alpha. Yeah, that's a small mistake here. So T sine alpha, FQ sine alpha plus mg, and cos 30 degree will be root 3 by 2. And here we can resolve these forces. What will it be? T cos alpha plus mg sine 30 degree, and sine 30 degree will be what? 1 by 2, right? I can just write it as 1 by 2 will be equal to this force, right? So this force, I can just write it here as normal plus FQ cos alpha. Okay, now just rearrange them. So it will be T minus FQ sine alpha will be equals to mg root 3 by 2, and this will be T minus FQ cos alpha will be equals to n minus mg by 2. So this I can take it as. Okay, perfect. So we have these four equations now. This is third, this is fourth. We know mg, right? So directly I can find alpha by dividing a third by 1, right? So I can write it as here 3 divided by 1. You will get, so t minus fq will get cancelled. So it will just be tan alpha will be equals to mg root 3 by 2 divided by mg into 1 by 2, right? Mg 2 will get cancelled, so we'll get tan alpha is equals to root 3, and alpha will be 60 degree. Okay, this is our first part. So second part, what it will be? Second part, in the second part we have to find the tension in the code, right? Tension in the code we have to find. So I can just put alpha 60 degree here and we will get it. So T minus FQ cos 60 degree from equation 1, right? Equation 3 divided by equation 1. And this is from equation 1. Mg by 2. Cos 60 degree, it will get cancelled. So T will be equals to FQ plus mg, right? And FQ we can write it as KQ square by L square plus mg. This will be our second answer. Third, okay, so C part I'm writing here. Okay, this is our, okay, so it's a first A, it's a first B, and it's a third part of A. We have to find the normal reaction. It's an again easy. We have this, we can use equation 4, right? So let's directly move on to the B part. The code is now cut, and what are the values? So these equation, if the code is cut, tension should be 0, right? So we can use this equation or this equation. So first we have to find this tan alpha. So again, equation 3 divided by equation 1, right? So it does not matter if T is there or not, tan alpha will still be 60 degree, right? Tan alpha will still be 60 degree. So that's it. This equation, from equation 1, we can write FQ cos 60 degree will be equals to mg by 2. So it will get cancelled out. FQ will be K, Q square divided by L square will be mg. So Q will be mg L square by K to the root, right? So this will be our answer. Yeah, it's a bit typical problem. You have to take, you have to give time, and it is a mistake prone because these resolve, to resolve these forces, you have to be very careful, right? So this is a hard question. It will take time. Let's move on to the sixth question. Wow. Let's move on to our sixth question. So, okay, we have three particles each of mass 1 gram carrying a charge q are suspended from a point charge from a common point by insulated massless strings, each 100 centimeter long, of the particle in equilibrium and are located at corner of. Okay. Wow, this is a again very hard question, I say. It's a tough question. So it's a very hard. Okay, let's try to solve it. So we have this equilibrium, we have this triangle, okay, and this is our point. Let's say this is our point. This is our point, right? Perfect. Now, one wire is like this, another is like this, okay, and another wire is like this, right? So this wire is in the background, okay, and there are no wire here, okay. So one of our charge is here, one is here, and one is here. Are you getting this? And this is up. So I should not like this. This is a pivot. Okay. Now these are 100 centimeter, and okay, so this must be small. Okay, I've taken it like very large, but don't worry, I will mention these values. So it's a 100 centimeter long wire, and this is 3 centimeter long. Okay, it's not a scale, so it should look like this, right? It should look like this, right? This is a pretty small, but I have to make the diagram bigger so that you will understand it better. Okay, perfect. So there are charges. This whole system is in equilibrium. So let's equate the forces here. So tension will be in this direction, right? And this charge will be repelling it like this, FQ, and this charge is also repelling it like this, FQ. Okay. So let's say this is L, and let's say this is A. Perfect. This angle will be 60 degrees, so this will be 60 degree. Now, let's resolve this tension, shall we? So, tension's one component will be here, right? And one component will be here, right? Okay, I have to take G also, so mg will be here. Now, let's say I'm just making a line here, this line I'm making. This line will be perpendicular to this line, right? Okay, so let me write it like this, right? Okay, so are you getting me? Let's suppose this is theta, right? So th if this is theta, then this will be theta. So this component will be t cos theta, and this will be t sine theta. Now, t cos theta is balancing mg, and t sine theta should balance the resultant of these two forces. So let me find the resultant of Fr. So it should look like this, right? Right. So this was our FQ. Okay. So this is Fr. Perfect. So let's first find Fr. Fr will be root f square plus f square plus 2f square cos 60. What it will be? So root, it will be 3f square, right? So Fr will be f root 3. Perfect. Now t sine theta will be balancing this Fr. So t sine theta must be balancing this Fr. So f root 3. Now what we have to find here? Calculate the charge Q. We have to find the Q. So I have to eliminate this t, right? So let's divide both of them. We will get cot theta is equals to mg by f root 3. Let's reciprocal it. So tan theta will get f root 3 divided by mg. Now the tough part here is how to find this theta. Remember, this point is what? This point is our centroid, right? This point is our centroid. So remember, always remember, from one vertex to other, this distance is what? How much? This distance is always come out to be a divided by root 3. Okay, and the this is the 2/3, so this is 1/3. It will be a by 2 root 3, right? So we just need this. So tan theta will be what? Now a is very small, like, so this triangle is like this. So this is very small compared to this. So theta will be small, right? Theta will be small. So I can write as sine theta will be f root 3 by mg. So sine theta is what? A by root 3, and this is L. So I can just write it like here. Yes, what it will be? So sine theta will be A by root 3, and this will be L, will be f root 3 divided by mg. So let's put these values: 3 centimeter divided by root 3, and L will be 100 centimeter, and F will be K Q square by A square. So 3 centimeter square into 1 divided by M is given, right? M is 1 gram. So I have to write it 10 raised to power minus 3 into G is 10, right? Let's cancel out things. So centimeter will get cancelled, and this will be root 3, right? It was root 3. So root 3 and 3 will get cancelled. So we will have Q square. So K will be in divide. So 3 centimeter here, it will be 3 into 10 raised to power minus 2 square to 10 raised to power minus 3 into 10 divided by what? 100 into divided by K. So K will be 9 into 10 raised to power 9. Right? Solve it here now, shall we? So it will be 3 square 9 into 10 raised to power minus 4 into 10 raised to power minus 3 into 10 divided by will be 9 into 10 raised to power 11. I can write it like this. So it will be 10 raised to power 10. This 9 will get cancelled. It will come up. So this is q square, right? So we'll get q square as 10 raised to power minus 17. I can write it as, so it will be what? So I can write it as q will be 10 raised to power minus 16, 8 and root 1 by 10, right? So root 0.1 is what? It will be 10 raised to the power minus 8 into 0.316. Yeah. So we will get 3.16 into 10 raised to the power minus 9 coulomb, which is nothing but 3.16 nanocoulomb. This is our answer. Okay. So we get this as our answer, right? It's a typical problem, definitely, but this approximation you have to consider it in the mind. Approximations are extremely important, right? Okay, let's move on to our next question. So it's a very hard again. Let's move on to our seventh question, shall we? Perfect. A small mass M having a charge 1 microcoulomb is suspended from a string of length 0.8. Another identical ball string charge is kept at a point of suspension. Determine the minimum. Okay, it's again a lengthy question here. It's an easy, but it's a lengthy question. Okay, so what is given here? Yeah, what is given here? Lengthy. Okay, okay, perfect. Now we have cir vertical circular motion. This, there is a particle here and there is a particle here, right? They are connected with a wire or string, yeah, of length L, and L is given 0.8 meters. We have to give certain velocity here so that it will complete the whole circle. Problem here is we have a tension as usual, we have a mg as usual, but there will be an extra force. This electrostatic force will also be there, right? Because they have charge and they have how much? Charge will be 1 microcoulomb, right? Each of having mass 10 in 2 into 10 raised to the power minus 3 kgs, right? So we have to derive this like we have done while uh, you know solving the vertical circular motion for different cases here, 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 right? Let's start the derivation, shall we? This is charge here, this is a charge here, this is our vertical line. Suppose this is making an angle theta. So T will be here. Let me change the pen. So T will be here, mg will be downwards, and here there is a electrostatic force of repulsion. Okay, this is a tangential, this is normal. Let's resolve it. So if this is theta, then this is theta, right? So here we will get mg sine theta, right? And here we will get mg cos theta, and it is going with the velocity v. Suppose this is v naught, let's say. So how we have derived this situation? We have to write two equations, right? One is one is force equation, right? And another one was energy equation, energy conservation, right? Energy conserve. We have to do these two, right? We have to equate the forces and then we have to write energy conservation equation, right? We have to conserve the energy. Let's do it. Let's equate the force in this direction. So what we will have, T plus mg cos theta minus F, yeah, will be equals to mv square by R. R is L, right? Now let's write this is our initial. Let's write the energy conservation here. This is our initial position and this is our final, right? This is our final. So what this says, it will be L cos theta and this is L, right? So you here and you here. Now let's equate the energy. Initial kinetic energy plus initial potential energy should be equal to final kinetic energy plus final potential energy. Initial kinetic energy will be half m v naught square plus. Okay, so u is 0. This is gravitational, but there will be a u, which it will be minus k q square by L, right? If this is 0, yeah, this is 0. This is u electrostatics is 0 here, right? So here it will be minus kq square by L. Okay, so this point, I should not write it as a line. Yeah, should remove this. So this point has u electrostatics is 0. So u electrostatic here will be minus kq square by L. Final kinetic energy will be half mv square plus final potential energy here. So ug will be what? Ug will be, yes, mg L plus L cos theta, right? Mg L plus L cos theta and ue. This is ug, right? This is ue. It's an initial. It will be same. If this is 0, then here the potential will be minus kq square by L, right? Okay. So in the direction of electric field, potential energy decreases, right? So electric field will be in this direction. So potential energy will decrease. So minus kq square. Okay, perfect. This will get cancelled out. Okay, now uh, just give me a second. Right. So we will have half m v naught square is equals to half m v square plus m g L. We can take it as a common 1 plus cos theta. Perfect. M will get cancelled out and 2 we can cross multiply. So v naught square will be v square plus 2L 1 plus cos theta. Perfect. Now let's put the value of v square here. Yes. So what we'll get here? It will be m by L t plus mg cos theta minus f will be equals to v square. Let's put it here. So v naught square will get m by L. So what we can do it like this. We can put v square here. Okay, so this will be more comfortable. Yeah, we can do this. Let's find v square from here. So v square will get v naught square minus 2L 1 plus cos theta. Now let's put this formula. Okay, so from 1 and from 2 we will get Right now, T plus mg cos theta minus F will be m by L. V square will be V naught square minus 2L 1 plus cos theta. Let's equate a little bit. T plus mg cos theta minus F will be equal to m V naught square by L minus 2m. G will also be there, right? G was there. Yes, G was here. G was here. So G will come out to be, G will be here. MGL. Yes, MGL 1 plus cos theta. Perfect. Now we remember, so remember the derivation. Yeah. At this point, at this point, this point, T should be greater than 0, right? So if I put theta equal to 0 degree, then T must be greater than 0. So T will be what? So let's first find T. Let's put theta 0, T plus, okay. So let's first find T. Yeah. So let's put theta 0. T will be mg minus F equals to mv naught square by L minus 2mg, and this is 2. So mg I can take it as here and F is here. F plus mv naught square by L, right? And it will be minus 5 mg, right? 4 and this one, right? Perfect. Now t should be greater than 0. So we will have F plus mv naught square by L minus 5 mg should be greater than 0. Let's rearrange them. Mv naught square by L should be greater than 5 mg minus F. Turned out to be V naught square should be greater than 5 GL minus FL by M. So V naught should be greater than root 5 GL minus FL by M. When you solve this, yeah, when you solve this, you will get your answer. Okay, everything is given. L is 0.8. F will have to find KQ square by L square, and we have L, we have M. I'm also given. Right? So, yeah, this is a pretty big question again. It's a lengthy one. Back to back, we are getting hard, lengthy question. Let's move on to our eighth question. Shall we? Let's move on to our eighth question. Okay, so video is already long, but to solve, right? Let's start. Okay, estimate the wavelength. I think there is a question missing here. First, we have to do the another part. We have to delete this. Must have another part. Yes, I found it. This is a question. Okay. Now, look, in this question, this is all nonsense. We actually do not need it. Just if we read the question, we'll get the answer. Okay. Just we need what are these parameters? So n is given. N is what? Number density of electrons. So number of electrons divided by volume, right? Perfect. Omega p is what? Angular frequency. Yes, angular frequency. What other thing? Epsilon naught we know it's given, okay? E is electronic charge and m is mass. Okay, perfect. Now we have to find the using dimension analysis, we have to find the omega p. So this is an actually easy question. So given lengthy comprehension, and this topic is like out of syllabus, you will not even understand what is happening here. But don't worry, just read the questions, you will get your answer. So omega p, we have to find the dimension analysis. Okay, so I'm not using the dimensional analysis here. Okay, I'll just write the units and then resolve it. This is a comparatively fast. Okay, let me show you. So what is the unit of epsilon? It's Coulomb square upon Newton. Yes, meter square, right? Let's resolve it further. Coulomb square. What is Newton? Kg meter per second square to meter square. So it will be simply c square upon kg meter cube into second square, right? The unit of mass is kg. The unit of n is what? It will be meter minus 3, right? What is the other thing we have? This mu. What is that? It's wrong. There is no mu here, right? And E we have. So unit of E is Coulomb, right? So I have to make omega p. And in omega p, there is only what? Second minus 2, right? So, okay, let's multiply things to the epsilon naught so that these other can be eliminated, these three. So, epsilon naught, what should I multiply it first, right? Uh, so, Coulomb square, I have to divide it by E square. So, Coulomb will get cancelled. So, Coulomb square, yeah. So, E square I have to cut it. Now, for kg, I have to multiply it by mass, epsilon naught into mass. Yes. Now here is meter cube. I have to multiply it with n so that it will be minus m cube. So it will be right. What we will get here is second square, but this is a unit of time, right? So I have to make it inverse. So omega will be so it's a t square. So omega square will be what? N e square upon epsilon naught m. So simply omega will come out to be root n e square divided by epsilon naught m. Right? Sometimes use like this because why I have done it like Coulomb. The dimension of Coulomb is Coulomb, right? What is that? Dimension of Coulomb is AT. So time will again come. I don't want this, right? So, right? So I don't want this, right? So I've just written all these quantities in SI units and then resolve it. We'll get answer. So it will be NE square by epsilon naught will be C. Okay. Now its second part is this. Okay, so this is its second part. What is saying? So this is our question number 9, right? Okay, estimate the wavelength of the plasma reflection. N is given, epsilon is given, and M is given. Okay, so we know the formula for wavelength. Yeah? It is V divided by frequency, and we know frequency. Yes, look, time period is 1 by frequency, and time period is also 2 pi by omega. So omega will be 2 pi nu, right? So, okay, so like omega, if I put here, so nu will be omega by 2 pi, right? So nu will be omega by 2 pi. So 2 pi will come up and omega will be here. So V by omega root n e square upon m epsilon naught into 2 pi, right? All the values are given, we just put it and we'll get our answer. So V 2 pi root m epsilon naught divided by n e square. So V, yeah, in the place of V, it's a plasma. So we have to write C. So C into 2 pi root m epsilon naught upon n e square. If you solve this, you will get answer 588 nanometer. So it's a near to 600 nanometer will be our answer. Okay. So this question is again very easy, right? This comprehension seems very complicated. It's a very lengthy, but when first just in the comprehension, even in class 12, Just read those questions. Okay, sometimes answer will be like on your tips. Okay, let's move on to our another question. Perfect. Okay, again about a big question, matching type, right? It seems easy. Let's see. So these are the charges we have. All are of same magnitude. All are of same magnitude, right? Fixed along minus 2a. Okay, this is their position, and this is a negative charge, right? No, this is again a positive. Okay, we don't know about these charges. These are positive or negative, but this is a positive. Perfect. Four options are given. We have to match. Okay, perfect. So first is a very easy Q1, Q2, Q3, and Q4. Okay. Now look. This situation is very symmetrical. Okay. So Q1 and Q4 will be applying same force, and Q2 and Q3 will be applying same force. But the situation is not that simple. We have to resolve them in the components. So let's try. So Q1 will be applying a force here, right? Similarly, Q4 will be applying the force here, right? Now, for the Q2 and Q3, Q2 and Q3, Q2 will be applying force here and it will be in greater magnitude. Similarly, Q3 will be applying force here. It's in greater magnitude, right? Now, look here. The resolve, if we resolve these forces, the component of this, right? This F4, I say, it's an F1, this is an F2, this is an F3, right? So horizontal component will get cancelled out. So F1 cos theta 1 will get cancelled out with F4 cos theta, right? So this is theta, this is also theta. So it will be F4 cos theta and this will be F1 cos theta. And F1 and F4 are equal, so it will get cancelled out. Similarly for F3 and F4, horizontal will again cancel out. So what net force will be there? It will be in the upward direction. So for Q1, Q2, Q3 and Q4, the force is in plus y direction. So for P, 3 is option. So there are two options. We do not need to check Q, we'll just check R, right? Let me rub this part again. Okay, perfect. Let's go back. For R is what? This Q1 and Q4 are positive. So again, this is Q1 and for Q4, this is our Q4, right? Now, for Q2 and Q3, they are negative. So they will be attracting it. So force will be like this, right? And for this, force will be like now. Let's think in a way of components. Look, this horizontal, similarly this horizontal and this horizontal will get cancelled out. Okay. Now look, this angle is small, this angle is big. So I'll say just it as a theta 1 and this is as theta 2. Okay. Let's name these forces, shall we? It will be F. It will be F. It will be F dash and this will be F dash. Now, which is greater? F dash is greater than F, right? Because Q2 is closer than Q1, right? Q2 is closer to Q than Q1 is closer to it. So F dash will be greater. Let's resolve the component in the y direction because x will again get cancelled out. It will be only y. So for F dash, this is Q2. Okay. So it will be 90 minus Q2 and this is 90 minus Q1, right? So component of F dash in y direction will be F dash sine theta 2. Okay, and again remember theta 2 is greater than theta 1. Okay, so sine theta 2 will be greater than sine theta 1. So it will be f dash in the direction downward. So f dash sine theta 2, it will be twice, and upward it will be f sine theta 1 will twice. Right? Are you getting me? Yeah, perfect. Now we know f dash is greater than theta 2 is greater. So 2f dash sine theta 2 will be greater than 2f sine theta 1. So the force will be in minus y direction. So for R, option will be fourth. So A option is correct. Yeah. So this is an easy question actually. We do not need to solve. Yeah. We just have to solve analytically, right? Quantitatively, we just have to solve it like this. Hmm. So it's an easy question actually, but it seems pretty big. Have to solve all the forces, right? But with the little mind, with the little analysis, you can just eliminate options and you do not need to check all the options and solve. You just quantitatively solve it. Let's move on to our next question. Okay, perfect. So we have two equal charges minus q fixed 2 point on the x-axis. Okay, it's a nice question. So they are fixed on the y-axis. It's a minus q. This is minus q, and this is capital Q. The distance is a, and this is 2. Okay, so this is a, this is okay, and this is 2a. Perfect. Now the Q will execute harmonic motion, or it will go like, okay, let's first check. Let's eliminate some options. It will be attracting it here, and this will be attracting it here. When the charge Q will went here, this charge will be attracting it here, and this will be attracting it here, right? Okay, just give me a second. Okay, perfect. So net force will be in this direction, right? So it is clearly executing oscillatory motion, right? So it will not come at rest at origin because at this point it will be having some velocity. So it will go forward in the minus y direction. So this is wrong, and move to infinity is also wrong. It will be doing oscillatory motion. Let's check if it actually oscillatory or simple harmonic. Okay, perfect. So let's find this force first. Let's say this is F1. Okay, the force will be same, right? So I just need component. Let's suppose this is angle theta. So F net will be 2F cos theta, right? So to F will be K Q capital Q divided by, okay, this is A, this is 2A. So this will be root 5A. So 5A square into cos theta. Cos theta will be base 2A. Okay, so for the SHM, I have to take some position, right? It's a mistake. So let's say, let me draw another diagram. Let's say this particle is at x distance, right? I've just moved it at distance x. Force will be in this direction, right? Perfect. And this is A. So what it will be? F net will be 2F cos theta. This is theta, right? So 2F will be K Q capital Q divided by distance. This is A, this is x. So it will be root x square plus a square. So it will be x square plus a square into cos theta. Cos theta will be base. Base is what? X, and hypotenuse is root x square plus a square. Right? This will be our net force. Of course, it will be in minus direction. So minus I. This is in vector. So F net will be, this is all constant. These are constant, right? So I'll write K dash will be x divided by x square plus a square to the power 3 by 2. Now, it looks like f is minus kx, but no. X is also here. So you will say, sir, let's do this. X square plus a square will be limiting to a, but it is wrong because x is 2a, which is actually more than this a square. So we cannot use this approximation. This approximation is actually invalid, right? So this is our force, and it is not directly proportional to x. So it is not SHM. It is a oscillatory motion. So A option is also option will be D. It is a only oscillatory motion. It is not SHM. Okay, right? It's a very interesting question, but easy one. Let's move on to our 12th question. Okay, perfect. Okay, so this is an easy question. It is question from gravitation itself, right? Gravitation, gravitation. So there is a plus q charge in the influence of plus q charge. Minus q is doing elliptical, moving around in elliptical orbit. So if it is moving in ellipse, so plus q should be here and minus q should be this, right? So plus q must be at one of the foci. Okay. Now we have studied this. If there are only two systems, one is sun and one is earth, angular momentum is conserved, right? Because the force is moving. The force is towards this plus q towards the sun, and if I write torque about O, it will be R cross F, right? So R is in this direction, it is 180 degrees, so torque about O will be 0, which means angular momentum is conserved, right? So angular momentum is conserved, right? So angular momentum of minus q is constant. Linear momentum cannot be constant because there is a force acting on it, minus q. Angular velocity is constant. So if L is conserved, right, that means m omega r square is constant. But R is changing, then omega must be changing. Omega must be changing. So this is wrong. Linear speed of minus q is constant. This is, I think, correct. No? No. Momentum is not conserved. So how can P is not constant, right? P is mv. Mass is constant. So V is not constant, right? So this is also only A will be correct. It's an easy question, right? The question is from electrostatic itself, but the concept we are using here is like kinematics, right? Also, we are using gravitation. So that is a interesting question. Let's move on to our 13th question. Yes, this is our 13th question. Two identical non-conducting solid sphere of mass m and charge q suspended from a common point by two non-conducting massless string of same length. Okay. At equilibrium, the angle between them is alpha. Sphere are now immersed dielectric liquid of this. Oh, this is interesting question. We have these two, right? Initially they were in equilibrium. Then what happens is this whole system is submerged in a liquid. Okay. Yeah, the density of liquid is 800 kg per meter cube. Okay, never mind. Now it seems if their angle is alpha, angle is C. You'll say, how is it possible? We will see that, right? Now we have to find these things. We have to find electric force, density of this sphere. Wow, and tension in the string. Okay, first let's solve for this situation. Okay, so we will have tension here mg in the downward direction and electrostatic force of repulsion in this direction, right? Electrostatic force of repulsion will be in this direction. Okay. Now, symmetrically, this will be angle alpha by 2. So here we will have this angle will be alpha by 2. So component of t in upward direction will be cos alpha by 2, and in the horizontal direction it will be in the right sine alpha by 2. Now, initially this FQ is balancing t sine alpha by 2 and mg is balancing t cos alpha by 2. So if I divide these two, okay, we do not need to divide it. Next, the final situation, what is happening is, let's write, let's suppose this is t dash. So it will be again t dash cos, okay, let me change the pen. So it will be t dash cos alpha by 2, and here it will be t dash sine alpha by 2. Mg will be downward and f will be here. F will be f dash, okay, this time. Next, will there be another force? No, right? There will be a force in upward direction, which is up thrust. Yeah, up thrust force will also be there. Okay, now this time let's write this. T dash sine alpha by 2 will be balancing f dash, and T dash cos alpha by 2 plus up thrust will be balanced by mg. Okay, now look, we have to find the f dash first. So f is what? K q square by r square, right? The distance between them. The angle is alpha, so this distances will be same. So f dash will be k. K is what? So let me write it completely. K was what? 1 upon 4 pi epsilon. Now this time it will be 1 by 4 pi 21 epsilon because the dielectric constant is 21, right? Q square by r square. So it will be F by 21. So if I equate this equation and this equation, right? So F dash will be F by 21. So T dash will be T by 21. So this is our first. We find the tension. Tension is reduced. Tension in the string holding the sphere remains same. This is wrong, right? Perfect. Electric force between the sphere remain unchanged. No, it reduces. This is wrong. So B is correct. Perfect. Next, mass density of the 840. So we have to equate this equation and this equation, right? So T dash was what? T by 21 cos alpha by 2. I'm just writing this here. Cos alpha by 2 plus U barabar will be equal to mg. T cos alpha by 2 will be mg, right? So I just write it as mg by 21 plus U equal to mg. So yes, what it will be? U will be 20 mg by 21. What is upthrust? Rho density of liquid volume immersed. So it will be total volume into G. 20 by 21. M will be what? Density of object into volume total. It is complete volume, right? Into G. So let's cancel out things. VT, G will get cancelled out. Density of liquid was 800. So 800 into 21 divided by 20 will be density of object, which will be 0, 0, 40. So 840 we got. Yes, 840 we got. Is it correct? Yes, that's correct. So option will be B and C. Right, one or more. So that is a very interesting question. Put it in the moderate. Why? Because the subthrust is actually forgetting, right? You can forget this upthrust words. So remember this. Be careful. Presence of mind must be there, okay? Without presence of mind, situation will be tough. Let's move on to our 13th question. 13th. Is it 13th or is it 14th? I guess it must be 14, right? Okay, no worries. Just move on to our next question. Yeah, it must be 14, right? This was 30. Yeah, this is 14th. This is 14th question. Perfect. We have three surface metallic spherical shell Q1, Q2, Q3. It is found that the surface charge density on the outer sphere of the shell are equal. Okay, the ratio of charges given is okay. So they are concentric spheres, right? They are concentric. This is one, this is two, this is three. Okay. Now the inner sphere has Q1, so it will be in the outer surface. Now this Q1 induces minus Q1 in the inner of the second sphere. But the second sphere has Q2 charge. So it must be in the outer surface, it must be Q2 plus Q1, right? Now, this Q2 plus Q1 will induce minus Q2 plus Q1, right? Let me zoom in. Yeah. So this Q2 plus Q1 will induce minus Q2 plus Q1. But the third sphere has Q3 charge, so it will be Q3 plus Q2 plus Q, right? So charge conservation we are using. That's it. Now let's find the sigma. Sigma of all three are equal, right? So sigma of 1 will be Q1 upon 4 pi r square. Sigma of 2 will be Q2 plus Q1. We are taking surface charge for surface charge density for outer surface. Okay. So let me mention it. It is a surface charge density of outer surfaces. Okay. Sigma 2 will be 4 pi 2r square. So 4r square I can directly write, and sigma 3 will be q1 plus q2 plus q3 will be divided by 4 pi 9r square. And all these three are equal. So let's equate these two. So q1 upon 4 pi r square will be equal to q2 plus q1 upon 4 pi 4r square. So r square 4 pi r square 4 pi will be cancelled. 4 will get multiplied here. So 4 q1 will be equal to q2 plus q1. So we will get 3 q1 will be equal to q, right? Perfect. Let's find another. Let's equate sigma 1 and sigma 3. So it will be q1 upon 4 pi r square. It's an easy question, right? q1 plus q2 plus q3. Outer surface charge density we have to take, right? So 4 pi 9 r square. Okay. Again 4 pi r square will get cancelled out and 9 will get multiplied here. So it will be 9 q1 plus. Can I write q2 as 3 q1? Yes, 3 q3. So this is 4 minus 9 will be 5 q1 equals to q3, right? So we have to write the ratio of q1, q2 and q3. So q1 as a q1, q2 we can write 3 q1 and q3 we can write as 5 q1. So it will be 1 ratio 3 ratio 5. This is our answer. So B option is correct. Yes, that's a very easy question, but we have to be careful, right? Okay, perfect. Let's move on to question number 15. Shall we? Last two questions are left only. Let's move on to this question. Okay, this is a moderate question again because here we will be looking at surface tension. So four charges, each Q are rigidly fixed at four corners of the sphere. Okay, so it's like this. So this is our square. Okay. Now these are our charges. All are Q. Perfect. Side is A. The system of charges and the planar film are in equilibrium. This is given. We have to find N. Okay, K is some constant. So look, this charge will be repelling this charge like this, and this will be repelling as this f dash. Similarly, this charge will be repelling this charge as f, and this charge will be repelling this charge as like in this direction will be f dash. Of course, these are 45 degrees. Now, let's consider this as a system. Okay, let's consider this as a system. Let's consider this as our system. Okay, now let's resolve these forces. So this will be f dash cos 45, and here will be f dash sine 45. Now here it will be again same f dash sine 45 because this is 45, and here it will be this f plus f dash cos 45, right? Now f dash sine 45 will get cancel out, but who will balance these four forces? It will be balanced by surface tension, right? So F plus F. Why? This F is due to fill fill at top, and this force will be due to film at bottom. Are you getting me? Right? Because a soft film has two layers, top and bottom, and these two surfaces will be applying forces. Right? Let's find this Fs I can write. So Fs will be surface tension into A, and surface tension is given what? Gamma into A. Okay. Now let's write the force equation. So this is 2F plus 2F dash cos 45 will be equals to what? 2Fs. Okay. So Fs we have. Let's find F and F dash. So first F will be what? F will be, it is simple, kq square by a square. But f dash will be this length we have to take, right? This length we have to take. So this length is a root. So f dash will be k q square by a root 2. It will be 2a square. Okay, let's just put it. 2 we can cancel out from all these three. F will be k q square by a square plus k q square by 2a square into 1 by root 2, and fs will be gamma. Yes, let's take common. Kq square divided by a square will be 1 plus 1 by 2 root 2 equal to gamma into a. Yes. Now a cube can come here and gamma will go down. So q square by gamma will be equals to k into 1 plus 1 by root 2 root 2. Right? So it will be plus 1 by 2 root 2 will be a cube. Now, if I take cube root, so this is all constant, I can write it as a c. This will be q square by gamma. It will be 1 by 3, and this will also be 1 by 3. It is. So this is some another constant. So n will come out to be, if I compare, n will come out to be 3. Right? So answer will be 3. So it's a moderate question. If you don't know surface tension, if you forgot, right, then it will be a problem. So it's a good question. Because the problem here is also, okay, so this 2 won't be any big problem because it's a constant, right? So it will get just come inside the k, right? So it's not a big deal. Perfect. So yeah, this can be considered as a like easy one also. Okay, next. The last question of this session is 16. Okay, perfect. This question is also easy, but I put it in the moderate. It's a moderate question. I put it as a moderate one. Okay, let's solve. So we have electric field over here. Let me zoom in a bit. Okay, perfect. So we have a electric field and this is our charge Q, right? Projected with the speed U at an angle theta. So we have to find theta, of course. I think the range is 5 meter and Q by M is given. Okay. So look, in a normal projectile motion, we have a G in the downside, but here, if this is Q, it's going like this. Okay. We are not considering gravity here. Okay. So electric field is in downward direction and Q is positive, so force will be in downward direction. And force is what? Mass into acceleration. So QE will be equals to ma. So A will be Q by E, sorry, Q by M into E, right? So this is our A. Sorry, this is our A. This is our A. QE by M. Okay. So in the place of G, we are going to use A. And this is a very simple question, right? It's going with the initial speed u, which is 2 root 10 into 10 raised to power 6. And A we can find. A is what? It's an electron or what? Charge is not given. Okay, Q by M is given. It's 10 raised to power 10 and E is 400 root 3. Yeah, so it will be 4 root 3 into 10 raised to power 12 meter per second square. All in SI units. Next. Perfect. So first we have to find the projectile will hit the projected angle at 45 degree or not. The particle will hit T if the angle is this. So let's just find the angle, shall we? Okay. So range is what? 5. The formula is u square sine 2 theta divided by g, not g, it's a. Okay. So 5 equals to u square. U square will be 2 to 4 to multiply 2 and root 10 will be 10. So 4 into 10 raised to power 6 will be 10 raised to power 12 sine 2 theta as it is, and a is 4 root 3 into 10 raised to power 12. So 10 raised to power 12 will get cancelled, 4 will get cancelled. This is 5 2. So root 3 by 2. So sine 2 theta will be root 3 by 2. Yes, and we have studied in projectile motion. Because of the sine 2 theta, we will have complementary angles for which the same range is possible, but time will be different, right? So just write 2 theta. I can write 2 theta as 60 degree. So theta will be 30 degree. And we will have another theta. Why? Because we can write 2 theta as 120 also, right? So theta will turns out to be 60 degree. For these two angles, the range will be same. Range will be same. Because why? Why? We have studied for two angles, right? For two angles, we will have same range. And these two angles will be complementary, right? What are complementary angles? Yeah. What are complementary angles? Yeah, tell me what are complementary angles? It's a nice class ninth question, right? Yeah, the angles whose sum is 90 degree. So for complementary angles, we're going to have same range. Okay, perfect. So like directly, I can just remove it. I can just remove this part, right? So if one angle is 30 degree, then other will be 60 degree. So it will be the range. Yeah. So A is wrong, B is correct. Now for two angles, time will be different, right? So let's find. First we'll take theta as 30 and second we'll take theta as 60. So formula of time will be 2u sine theta by g. So 2u will be, u was what? 2 root 10 into 10 is to power 6, right? Sine 30 will be 1 by 2 and G will be 10. Okay, so 1, 2 will get cancelled out, and this is 10 raised to power 6. 10 is power minus 6. It was minus 6 or plus 6? Yeah, it was minus 6 or plus 6. Is plus 6 right? Okay, oh, okay. Yes, look, these are these mistakes, not G. It's A, right? Sorry, it's A. So A will be 4 root 3 into 10 raised to power 12. So this is 10 raised to power 6. Okay, 2 will get cancelled out here. So we will have root 10 by 3. This will be 1 by 2. And 10 raised to power 6 will be micro s. Yes. So 2 will come inside the root. It will be 4. So it will be 5 by 6. So root 5 by 6 microsecond. For theta equals to 60 degree, we can find t will be, okay. So for theta will be 60 degree. Instead of 1 by 2, we just have to write root 3. Yeah. So it will be root 5 by 6 into root 3. So it will be root 5 by 2 microseconds. So this C option is also correct. Time taken of the particle is this. Okay, perfect. So these are our 16 question. So if I summarize, in these 16 questions, like 2 to 3 were hard, right? 2 to 3 were moderate, and others, like say 10 questions, they were easy, right? So it will be always like that. Don't worry about it. The JEE Advanced will be very easy. You just have to solve. You just have to pick the right question. If you pick the hard ones, you might stuck. It will decrease your confidence, and hence you won't be able to even solve easy, even if you find them, right? So the presence of mind must be there. Okay, so presence of mind must be there. Okay, and don't lose confidence. Don't don't yes, don't lose confidence. Even if you find 2 3 questions are hard, don't lose confidence. Just keep on moving. Okay, keep moving. Right, if you have these three qualities, everything will be easy. Okay, so let's finish the today's session. Bye bye.